This is my custom-made Macropad that I call the Switchboard. It controls everything from my air conditioner to my smart home devices. Its main use is to input macros into my computer to control OBS and also display information such as Spotify music and other stats on its OLED screen. In this video, I'll go through how it works and how I designed it. So first, we need to figure out what kind of functions we want from this device. I listed these out and grouped them. I'll go over the functions at the end of the video. While listing these functions, I've listed out the method of communication, whether it's the Macropad simulating an F15 key press or sending a request through Wi-Fi to trigger an action. Through Wi-Fi? That's right, the heart of every keyboard or Macropad is a microcontroller unit. It's basically a brain that converts your physical key presses to keystrokes in your computer. With this project, I've decided to go with an ESP32S3, which is a microcontroller that has built-in Wi-Fi and Bluetooth capabilities. This means I can map any key press to interact with any endpoint on the internet or my local network. How cool is that? I've spent a good part of the last year prototyping and iterating a development board, which I'm thinking of making available as merch for you guys to purchase and play around with. Let me know what you guys think in the comments. Back to the Macropad, now that we know roughly how many functions we want, we can draw a mock-up of the layout, which gives us a good idea of what it'll look like. I realized that there's no OLED that I can buy in this shape, so I ended up going with a different layout. The OLED that I picked was a 3.12 inch SSD 1322, and it comes in different colors like yellow, blue, green, white, but I ended up going with white. Now I have to design the footprint for the OLED so that we can mount it onto the PCB. The software I'm using here is Eagle, but I would also highly recommend KiCad. We just gotta lay out the switches here. We have to lay them out onto the PCB. Now I just have to position where the rotary encoders will go. And this is me wiring up the rotary encoders on the schematic. Next up, I have to wire up the infrared LED with this MOSFET, which amplifies the signal from the microcontroller. Now I just have to connect the OLED pins to the microcontroller. And that's the PCB done. I have to design and model the case. I'm using Fusion 360 for this, and I have to thank Alex Banks for his tutorials, which really helped me learn Fusion 360. I'll link his socials down below. And that's it, and now I have to get these manufactured. Which brings us to today's sponsor, JLC PCB. JLC PCB is my chosen manufacturer for PCB manufacturing and CNC machining. I've dropped my affiliate link down in the comments and description below. I received my manufactured pieces about a week after placing the order. It's time to open them up. I was really quite happy with the quality of the finished PCBs. Look at the quality of that gold plating. Now for the machined parts. I had the switch plate made out of FR4 and it looks great. Same goes for the aluminium. I chose a sandblasted finish and the fish looks pretty good as well. The bottom brass plate is also sandblasted and is pretty heavy. It does tarnish a bit easily though. Now it's time to solder everything together. While test mounting, I realized that the buttons on my development board were too tall, so I had to desolder them and use some low profile ones instead. Now I have to solder these spaces so that the OLED can sit on top. I've designed the OLED to mount using spring-loaded pogo pins. That means if the board breaks, I don't have to worry about wasting an entire OLED screen. Now it's time to solder the blocking diodes for the keypad matrix. After doing some testing, I realized I made some mistakes and forgot to connect the columns and the rows of the switches to the microcontroller, so I had to do a few bodge wires. I wasn't too happy with the sound of Cherry MX Reds, so I got my hands on some Hymugeon silent red switches and replaced the MX Reds. This is what it sounds like before. And after. And after a lot of coding, this is the result. At all times, it shows the status of my mouse battery level, as well as the temperature of my CPU and coolant on the left status panel. It also tells me information about my Wi-Fi status and the link between my Macropad and computer. In the main panel, it will tell me what's playing on my Spotify account, or when it starts streaming, it will show stats such as viewer count and whether my delay is on or not, because I have a dynamic delay system set up so that I can turn it on if I feel like I'm getting stream sniped. I also have keys mapped to turn my delay off or on at will. The 6 middle keys here are bound for controlling scenes in OBS. The grey keys on the top right of the Macropad can be pressed to control my air conditioning unit, which sits behind me. I can also turn the knobs to change volume within the Spotify player or within Windows itself. I use the bottom right key to compile and upload my code, which helps streamline my workflow. If you guys have any technical questions, let me know in the comments below, and I'll try to address them in a future video that I might post on my second channel, which is also linked in the description. So that's it. And to answer a question, which a lot of people will probably ask, can you buy this? I didn't originally intend on making this a purchasable product because it was more of a personal project and I haven't written a front-end user interface for it. This means that if you did have this in your hands, you would need to know how to code and how to program all the functions. However, this did end up a lot cooler than I thought it would be, and if you're truly interested in purchasing one of these, please let me know in the comments how much you'd be willing to pay, and I'll see how it goes. If I do end up making more of these, I definitely would implement some improvements such as an anodized surface finish, and maybe also implementing some of the cool features like a built-in USB hub, and using dye sublimation for custom keycap symbols. Also, this is my first keyboard project. I've never built a keyboard before, I've never modeled a keyboard. I use all my keyboards stock, and in hindsight, I think I definitely could have implemented some sort of noise dampening solutions. Anyway, I hope you guys enjoyed the video. I'll see you guys next time. And using dye sublimation for custom keyback. And using dye sublimation for custom keypad. And using dye sublimation for custom keycap symbols.